Hi everybody. I would have to say that the number one most recommended thing or requested thing on my channel has been Model 6 and Model 7 for process in SPSS. So this video is going to cover Model 6, and then a soon to come video will cover Model 7. So I always recommend opening the templates.pdf that comes with process when you install it, because I think it really helps me see what the model's trying to achieve, especially as you add more mediators, more moderators, or covariates. So this particular model covers double mediation, where we have one X that we think goes through two mediators before it hits Y. You can do up to 4 mediators with Model 6. I have no desire to look at even half of that, so we're going to do just 2 mediators because 3 and 4 mediators is just variations on the theme. So we're going to work through the whole thing from start to finish, showing you data screening and then how the model works, how to interpret the output, and just a quick kind of small guide on APA. All right, so that's templates.pdf. It comes with process. All right, so what this data set has is some made-up data that I'm using. So it doesn't work perfectly, but it'll be a good example of how this works. So 1 X variable, 2 M's, and a Y. And what I've done is I've taken that example picture from Hayes' guide to write on as we go. Let me make it a little bigger here. And so I just kind of made up this example from some grading data. So what we have is our course evals that we all know are notoriously problematic. And what we did was we looked at, and we didn't do this, it's made up, but the grade that the students are making in the course, so they think they're making, predicting the fact that they like the instructor. So this question is like, this instructor is in the top 20% of all courses that I've had at the university. But we think that the grade that they're making really predicts whether or not they like the instructor, but maybe it's mediated by how fair they think the grading is and how much they think the exams and assignments match the lecture. So maybe that grade is in part due to the fact that they think the instructor is fair and that the items are easy to study for, which then predicts that they're the best instructor ever, right? We had another question on here this is a course I wanted to take that also does some funny things to your instructor ratings, especially if you teach statistics. So let's look at the data set here. This data set will be available on Stats Tools after I'm done. If you haven't checked out our website, it is really awesome. We have tons and tons of materials. If you're looking for SPSS or R, and what you do when you get here is you click on the sidebar to see all kinds of different courses that I have taught, and all of their core materials. You can look from it for here. You can read about our Facebook page. You can look at our applications. So all of this is on here, or it will be when I remember how to upload things. And what you do is you click, for this one, it's usually Advanced Stats Examples. And then here is my other couple of ones for mediation and moderation as well. One thing we're working on this semester is adding links to all the materials on YouTube so that you can find them a little easier. But all that aside, let's talk about double mediation. So the first thing we're going to do is practice data screening. So most of this data screening is taken from either the Andy Field book or the Tabachnik and Fidel book. I do use the rule where P is less than 0.001 before we decide that anything is problematic, which does not match the field. That matches the Tabachnik book. Okay. So first thing I always want to do is make sure that these averages, which is what they are within range. So we're going to check for accuracy first. So I'm going to do analyze, descriptives, and then I can do frequencies or descriptives. Okay. I'm going to move everything over. But I'm going to turn off display frequency tables because these are decimals and that'll make me these giant tables. Under statistics, I can get the min and the max just to make sure that they look right. I also usually like to ask for mean and standard deviation just to make sure that nothing seems crazy out of the normal size. Continue, hit OK. Let's see what we got here. All right, so for all of them, I don't have any missing data, so that's fortunate. I don't have to look at that step. I have 3,500 cases. The means for the questions don't seem too irregular. They run from 1 to 5, so I don't have any that are out of range that I need to fix. And the standard deviations are about half a point. So none of this looks too wild. It's within the range I would expect for these 1 to 5 Likert scales. So the next thing you always check after accuracy is for missing data. I don't have any missing data, so I don't have to worry about that on this example, which is good. The next thing we're going to do is check for outliers. Because this is regression style data, we could actually test this using all of our predictors predicting y, which is part of the steps for double mediation, but you can't actually do it through the process plugin. So there's a couple of ways to approach this. I'm not saying my way is the best way, but what I'm going to do is just use Mahalanobis distance to see if the pattern of answers across all 4 variables is unusual. You could also do traditional regression style outlier analysis, but I would do that on the step with all of the variables included. So X, M1, and M2 predicting Y, and use either Mahalanobis, Cook's, or leverage. So either approach is appropriate, and then there are other ways to do this. Okay. But let's say we just want to look at Mahalanobis values, and we want to do this for all 4 variables because we just want to see if the pattern is unusual across all 4 of them, since we're going to use all of them in one way or another. To do that in SPSS, one thing you can do is create a random variable. This is from the Tavachnik book. So I'm going to do transform, compute variable. I'm going to call it random because then I'll remember what it is. Over here under function group, I'm going to click type R till I get to random numbers. And I'm going to use RV chi-square. Okay. Chi-square because the residuals and Mahalanobis values and a lot of these assumption tests are chi-square distributed. So we want to create a random variable in the same distribution. If you've watched a lot of my videos, you'll see that I picked the number 7. It works for me. You really need anything bigger than 2. Otherwise, you don't get enough variance for this to give you a picture. So pick something a little bigger than 2, but you don't have, and there's no reason for 7 other than it works. All right, so that created me this random variable. Now to get the assumption tests and Mahalanobis, what we're going to do is analyze, regression, and then linear. I'm going to predict my random variable. So none of these variables should be very good at predicting a random variable, which is why the scatter plots of residuals should look random, as well as the residuals should also hover around 0 because some will be high and some will be low, but they shouldn't create a predictable pattern. So I'll move all 4 of these over. Because I have 4 of them, that makes my degrees of freedom 4 for this next analysis. So it's the number of things that you put in this independence box. Under, nope, not statistics. Sorry, this has been a while. Under plots, do Z-pred for Y, Z residual, and X. That's going to create us a residual statistics plot for checking homogeneity and homoscedasticity. Click on the histogram button for normality and the probability plot for linearity. Click continue. Under save, click Mahalanobis. Now you could do all 3 here as well, but Cooks and leverages really depend on you predicting Y, so I wouldn't recommend it. Okay. If you want to use the all 3 method that I've shown in some of my regression videos, you should do X, M1, and M2 predicting Y, not this random thing. Okay. So click continue, and then click OK. We're going to get some output, but I'm going to ignore it for right now. I'm just going to look at Mahalanobis. So for that, I need a chi-square table. So the cutoff for this is chi-square distributed, which is why we made up a random variable with chi-square. And I'm going to use 4 because I have 4 variables, X, M1, M2, and Y, and P less than 0.001, because we want things to be really nuts before we correct them. So I have 1847 would be considered an outlier. So I'm going to sort Mahalanobis. Now on Mac, sometimes right click and sort doesn't work. So what I'm going to do is do data, sort cases, Mahalanobis, and descending. It's always positive. That helps us out a lot. So I clearly have some wild answers here where a student hated a professor, but then they rated all of the other ratings pretty high. So that looks kind of like a typo. So what we're going to do is first move the cat, who's decided to use the computer as a scratching post. All right, is we're going to get rid of everybody who's over 18.47. So I can filter those out or I can delete them. I highly recommend saving data sets as you go so that you don't actually lose participants. So what I would normally do is do File, Save As, and call this No Outliers. Save. And then delete anybody over 18.47. So hopefully this doesn't make my effect go away. I still see the same results because otherwise I checked whether or not this worked before I data screened. All right. So we have our No Outliers data set. Great. Now all the output I have here is now incorrect because these charts are based on having those outliers. So what I'm going to do is rerun that regression. So analyze, regress, linear, and just click OK. Now I will get another Mahalanobis column out here, but I'm going to ignore that. You don't want to double delete. So these people were outliers given the data I had. I don't want to delete them again. So let me close this thing so my computer doesn't freak out. And now let's look at those charts. So I'm not going to look at the first one because the first one includes the outliers. So this first thing here is normality. I would say this is all right. We have a huge data set. So even with deleting a couple hundred people or not even 100, 20 or 30, I still have 3,500 cases. I'm well past the n equals 30 for normality, so I'm not too worried about it. But when you're looking at these charts, what you want to look for is between 2 and 2. Okay, are most of the bars centered over 0 and between 2 and 2. This one does have a slight skew to it, although most of the data is between 2 and 2. It is slightly higher, so it has a slight positive skew. Then we'll check out linearity. Oh, it's questionable. I don't tend to get too concerned when it bows away from the bars a little bit unless it starts to make a big S shape or it looks like a bow and arrow. So I'd probably say this was okay. Remember to use the squint test. So if you squint at it, it kind of looks like a line. It's probably fine. So this is not great, but it's all right. Now this is actually quite bad. If you want to see it a little better, you can double click on it and tell it to add a line of best fit. Add fit line at total. I think that'll work. Can't ever remember. Yeah, it usually adds a line at 0 for you. It also gives me the regression line, which I didn't really want, but that's okay. Ah! You can tell I've been making R videos for quite some time now. I don't remember how to do any of this. Close this. All right, well, I have the fit line, but I didn't really need it. So here, across 0, for homogeneity, what we want to see is across 0 in both directions, we want to see the data is evenly spread. So from 2 to 2, normally, it's a common theme because these are z-scored. You want most of the dots to fall. Here we're running 2 to -4, that's not so hot. And then here on this axis, so horizontal axis, oh sorry, that's vertical, it's running 2 to 6, so that's also not good. So I would say this data is probably not homogeneic, right? That's considered raining. For homoskedasticity, what you want to see is an even spread of the dots, regardless of the zeros. So you have to kind of ignore the zeros and draw a line around the dots. And this one's actually not too bad. The problem is that generally most of the dots here are concentrated right in the middle. And so the issue becomes the fact that there is more of a spread this way. So when you have this many dots, it's kind of hard to see. But I would say this one's actually probably okay because the spread of the dots is roughly even across most of where the dots are. These are the problem dots out here that we're going to have trouble predicting because they are likely not falling within the same range as everybody else. And so I would say this data set's kind of And a better option might be for me to try this in R and use some nonlinear regression or some rank regression that would deal with these, what are going to be difficult residuals. But for the purposes of this video, we're really talking about process, which is part of SPSS. So that's how you would check for accuracy issues. We didn't have any missing data. We talked about outliers and assumptions for regression test. So the next thing we're going to do is actually try process. So let's close this thing. Keeping this picture in mind, we're going to run this model. Okay, so analyze, regression. I'm going to go down here to the process plugin. Hayes' website explains how to install said plugin. So I'm going to click on that. And then what we're going to do is, I'm going to hit reset because I had already done this, but we're going to stick X into the X variable spot, Y into the outcome variable, and then both moderators go into M. Okay. I'm sorry, mediators. I keep saying moderation, my fault. This is all about mediation. Ignore me if I say moderation. I'm also dealing with a very needy cat that is like wanting all of the attention. So Andy Field would be excited because there's cats not in the video, but at least as part of the video. All right, so we've got both M's in there. Now, the order that M1 and M2 will show up in is in this order. So if you decide you want to switch the order of them, you can click on one of them and drag them into a different order. So that will control which one comes up first as M1 and which one is M2. So they're not separate boxes anymore. We want to change model number to 6 over here, or we will not get the right model. Under options here, what we want to do is pick effect size for models 4 and 6. So we can see the effect sizes, although I would recommend looking at what they are because they're not what I'm used to seeing. We won't get the Sobel test because that's model 4 only. So I also want the total effect model 4 and 6 and compare indirect effects for 4 and 6. So click continue. Conditioning is for moderation, so I don't need that. I don't have any categorical variables, but I'm really excited to see that he's added these multi-categorical options. So if you have categorical variables, this is how you can change which one is the indicator variable for dummy coding. And then the long names option, which is the long time coming, that'll let you continue without changing the variable names if you have more than 8 characters. Woo! So great updates to process here. So I'm gonna click OK. Now let's look at this output. After it runs. I do have a very big data set, so this does take a minute to run. There it goes. So let's go through what's in this output sort of one piece at a time, although most of the action, the part where you're going to be interested in whether or not the mediation really happened, is here, down here at the bottom, total direct and indirect effects and the total effect model. I found it a little easier if I just kind of start at the top and label them all, and then I can think about the picture. Okay. So the first thing we get is X predicting M1, and its coefficient here, unstandardized coefficient, is 0.51. So I've got this X predicting M1 here, which is the path A1. And so we're going to add a little text box here. Oops, what happened? Okay, well, I thought I could add a little text box here. There it goes. And that was 0.51. So the grade I'm making predicts whether or not I think the professor's grading scheme is fair. So it may be that I think the grading scheme is fair and therefore I do better in the class, but if I perceive that I'm doing really well in the class, I think the grading's fair because I'm doing a good job. So clearly all you people who are making Fs are just complaining because you are dumb. Something like that. Okay, so that's a significant effect, and that's good. We need X to predict M1. Okay, I can tell it's significant over here by looking at P. And if I wanted to write this up, I would use T here at 3055. So this is APA style. If I can work a word here. Come down here, thank you. So I do T, don't auto capitalize, 3555 equals, I pull that T value, so 6590. Okay. I'd say that P is less than 0.001, right? Because it is here. You could also include the model statistics for this. So our R squared is 0.55. Since this is only one variable, that variable predicts M1 quite a lot because all of that R squared is due to this one variable. Okay. But the real focus with mediation is really to look at the individual variables predicting. And I don't know that overall model statistics, while they're great, I don't know that it's necessarily the most interesting part of this analysis. So now we're going to predict M2. So I got X predicting M2. So I got 0.61. This is considered A as well, but it's like sort of A2, if you will. Oops. So we said this is 0.61 over here. Okay. And so that means that the grade I'm making predicts that I think that the grading matches what's in the lecture. Now for this one, what I would do is have T, but the degrees of freedom are going to change because it's a different model, so 3554, and that is equal to, let's see here, 2391, so that's a big effect, and it is significant. Okay, it's significant because it's less than 0.005, or I'm sorry, 0.05, single zero. I'm writing them as 0.001 because APA 5 and 6 indicate that we should use exact p-values when reporting. And that's the closest, that's sort of the closest thing we can get given our output. Generally, people stop at 3 decimals. Yeah. All right, I'm not reporting B because I'm putting it in my picture here. So now we need M1 predicting M2, and this is the one where I said it doesn't really work, but that's okay. And so in this model, it would be kind of difficult to argue that this is double mediation because this path is not significant, but for example's sake, it's 0.04, okay, and that's not significant here. Ooh, what did I do? I am terrible at working Word today, good gracious. There it is. So it's 0.04. So the fairness that I feel doesn't seem to predict whether or not I think it matches the lecture, but that's probably because fairness isn't in there with the grade I'm making, and that is such a strong predictor. So this may be a little bit of suppression here because these might all be so highly correlated that's difficult to tell. But what would be really better is if fairness predict matched lecture as well. And so we really need M1 to predict M2, but it doesn't in this case. Okay. This would also be 3554. Our T value is less than 1, so it's clearly not significant, 0.097. And our P value equals 0.33. Right? So now we're going to predict Y. And in this particular model, this last model, I have all of them predicting Y. So this is the sort of model with the indirect effects. So I've got X is 0.03 now, so that's good. It's a small number, which is gonna probably be what we're looking for. So that's C prime, which generally is written on the inside in the pictures I've seen. And now we have, let's see, M1 predicting Y. Well, that's not really on here. Here it is. So let's see. How much does M1 predict Y? So I got 0.31. So what I think is happening is the fairness predicts whether or not they think you're a good instructor, which is a good thing. If they think that you're fair, they think you're a good instructor. You always want to be fair. Okay. And M2 here, 0.07, is also a predictor. So if they think that your tests match the lectures that you're giving them, so there's a match between class and exams, they also like you. But it seems to me like fairness is a little bit stronger. These are all in the same scale, so while they're not beta, I can compare them a little bit. I can't say it's significantly different without doing some tests. Oops, wrong button. But it seems to me like this one's a little bit stronger. So now I have all of these filled in except C. I really need C. That's usually the first step. Okay? So I have that everything is predictive except M1, M2, which is kind of a problem. But let's look at X to Y. Okay? So right here underneath this last one, now I didn't write these in, so they would be 3, 5, 5, 3. Let's do that real quick. Okay? So we've got T 3, 5, 5, 3 equals, we're going to have to do X 2.21, P is 0.03. Okay, so it's significant, which may not be the end of the world. Remember that your mediation does not have to totally eliminate the relationship. That's sort of like the original view of mediation, was that X to Y went totally away. Well, this is a huge data set, so we've got some issues with sample size might be pushing significance here as well, but it doesn't have to totally go away. It could be partially mediating it, or it's just about moving the relationship between X and Y through M instead of all through X and Y. So it's sort of about redirecting that relationship that's there. We haven't tested that yet. We're almost there. We've got M2, so we've got 1578 and 7.42. So 3553, 1578, and that one is significant. And then T3553 is 7.42, if I can remember correctly, P less than 0.001. So that would be all the predictors for that step. Last but not least, we need C. So we've got X predicting Y all by itself with nothing else, and that's 0.23, and it is significant. So we dropped 0.2 points. Okay, and that's considered the indirect effect, which is the direct effect minus the total effect. Okay, or total effect minus the direct effect, either way. So the indirect effect, the total amount of it is 0.20. So we're going to get down here and figure this out here in a second, but let's write this one up. So it's 3555, it's 2452. Okay, and it is significant. Okay. So at this point, what can I say? Do I have mediation? Well, adding M1 and M2 has eliminated the relationship between X and Y quite a bit. Not totally, it's still significant, but it looks like it has done something, because C and C prime are clearly not the same number. All of my variables are predictive except here, so it may be that there are two mediators, but they don't have this linear path between them. So they both mediate the relationship between X and Y, but it isn't 1 to 2 to 3 to 4. So 1, 2, 3, 4 here. So this model may be better as separate mediations and compare the mediations to each other. So two versions of model 4 compare to each other. Or it may be that we've got the order wrong. So there are a couple different things that maybe you could try if they were theoretically meaningful. Now, how to interpret the rest of this? Because that's pretty straightforward if you just label all of your variables. But down here under total direct and indirect effects, what's happening? So total effect is C. The direct effect is C prime. The indirect effect here, if I can get double click to activate, go away, is here. This total is 23 minus 0.03, or 0.23 minus 0.03. So that's where that 20 comes in. Now you notice there's no significance values out here, and we didn't get Sobel because it actually is two different Sobel tests. So what I really want to do is I want to look at the boot confidence interval here and see if it crosses 0. Okay, so it's 20 here. I don't want this to cross 0. You don't want one to be negative and one to be positive, and it doesn't. So it appears to me that this effect is significantly different from 0, because the confidence interval does not cross 0. So that implies to me that total across M1 and M2, we are mediating the relationship between X and Y because that indirect effect is not 0. But then you also get these 3 indirect effects. Okay? Now, what you should do is sort of scroll down, and you'll see here what that key is. So indirect 1 is X to M1 to Y. And so that's basically a single moderation. So part of that total indirect effect is X through M1. Right? So it breaks them down. You'll see it adds up to the 20 up here. So most of that action is happening through M1. And that is significantly different from 0. Due to the confidence interval here not crossing 0. So most of the total effect is X to M1 to Y. You'll see indirect 2 here. So indirect 2 is X to M1 to M2 to Y. So that's the rerouting it as 1 to 2 to 3 to 4. And that one is not significant. It's very close to 0, and it doesn't seem to support the notion that it is 1, 2, 3, 4. Instead, it looks like it's 1, 2, 3 is where the most of the action is happening. And that's really because these two variables don't predict each other. Or M1 doesn't predict M2. And so I probably wouldn't say this was double mediation. I would say that M1 is clearly a mediator. Now, into 3 here is X to M2 to MY, to Y. And that one is a mediator. And it's above 0, but it's clearly less than M1 here. And so really what it looks like it's happening is I do have 2 mediators, but the 2 mediators aren't related to each other. So I have 1 mediating and 2 mediating, but they don't go through this path of 1, 2, 3, 4. What it looks like is happening is there's 2 routes to get to Y, but there isn't this third bypass, if you will, to use a terrible road example. Okay, the other thing that the output will give you is the different effect sizes. So we've got partially standardized direct effects, completely standardized indirect effects, ratios of those effects. I would tell you to read what Hayes has to say about these and which one he recommends currently. I know the Preacher and Kelly option has been taken out of this version. I'm using 2.16 in this video. So I'm not sure which one I would recommend because I haven't looked at these in a while and which one is best. I might recommend completely standardized, but you'd probably want to get it from the man himself on which one is the best effect size. But either way, just telling people which one you're reporting would be best, and be sure you include the confidence interval so that they can judge for themselves that these are greater than 0. The other thing that you can hear are these little C's. The C's are comparing the indirect effects to each other. So these are sort of like little mini t-tests for which indirect effect is better than another in a sense. So I've got 1 to 2. So the indirect effect of 1 versus 2 here. Now 1, remember, is X, M1, Y. So this is sort of testing M1 by itself. 2 includes both mediators. So 1 to 2 clearly, looking here. 1 is a much better one. And I can see that by knowing that that's one is the 15 one. So those are significantly different from each other because, again, it doesn't cross 0. And then C2 down here is 1 to 3. So we're getting these pairwise. So 1 to 3. And it seems that M1 is a much better mediator than M2 because 15 is greater than 4. And that is significantly different. So 1 is better than having 2 of them, and then 1 is better than having M2. So M1 is better than a lot of these other things. And then the last thing is C3, which is 2 versus 3. And those are different, but it's basically saying M2 is better than having both M1 and M2 together. So to kind of sum all this up, what I tell you to do is to report maybe these indirect effects box's own y, all of the different predictors here, and then an interpretation of how those predictors lay out and what they mean for your particular theoretical model. So feel free to ask questions. Let me know. Model 7 coming very soon.